Hi everyone, I'm Zulaika Binti Muhammad Rosli from class M4T16.
I'm Sharifah Batrisyia Binti Syed Nasir from class M1T1.
We are from Perak Matriculation College.
We are going to do an experiment about osmosis and we will explain the process in this video.
Have you ever think how does orange water is formed? Do you think orange water is formed by absorption?
I don't think that is the right term to explain the process.
Let's do an experiment to find out the answer.
What is the materials and apparatus needed for the experiment?
The experiment that we are going to do is very easy. We need some warm water and food colorings for the materials. Then we need to prepare a few cups and some paper towel for the apparatus.
Let's get started.
The interesting experiment that we are going to do is called walking water. We are going to use 3 cups, 2 paper towel, 2 color of food coloring which is green and orange color, then we need some warm water. We are going to get our paper towel and pull off a square of paper towel to be folded twice. We need 2 of them again and we are going to fold it into half for once and then fold it into half twice. Firstly, place the cups in a row and fill the cup with half of warm water. Drop some green food coloring into the water of the cups that we used in.
We are going to put one end of the first paper towel into the green water, while the other one end will be placed into the empty cup. Then we need to place the one end of the second paper towel into orange water, and the other end will be placed into the empty cup. We need to wait for about half an hour before we are going back to check the experiment and see the amazing result.
From the experiment that we have done, we can see that the food coloring can go through the water molecules because of osmosis process.
For your information, osmosis is the movement of water molecules from a high concentration to lower concentration through a cell's partially permeable membrane.
When you are talking about osmosis, you are talking about the movement of water through a semi-permeable membrane, like a cell membrane. Water molecules are so small that they can travel through the cell membrane unassisted, or they can travel in larger quantities through protein channels like aquaporins. The movement of water molecules traveling across the cell membrane is passive transport, which means it does not require energy. In osmosis, water molecules travel from areas of a high concentration of water molecules to a low concentration of water molecules. But there's another way to think about water movement in osmosis. A low water concentration likely means there is a greater solute concentration. Solutes are substances like salt or sugar that can be dissolved within a solvent. Like water, water has the tendency to move to areas where there is a higher solute concentration, which would mean less water concentration. So if you want to easily figure out where the water will travel in osmosis, look to the side where there is a greater solute concentration. Unless we bring in another variable, like pressure, water will generally have a net movement to the area of higher solute concentration.
To get a more clear idea about osmosis, let me show to you the application of osmosis in our real life. One of the examples is kidney dialysis treatment. In this process, waste products from a patient's blood was removed through a dialyzing membrane. The patient is then connected to a dialysis machine, which also called as a hemodialyzer. But before we are going any further, let's watch a simple animation about how dialysis process works.
If the kidneys become diseased or fail, it's a serious health problem. Because excess water and waste products from the body's metabolism can no longer be filtered out of the blood. To prevent toxins from accumulating, the blood must now be regularly cleansed with the help of dialysis. The most widely used form of dialysis therapy is called hemodialysis. At the center of hemodialysis is a dialysis filter, known as a dialyzer. Serving as an artificial kidney, it cleanses the patient's blood during the treatment. Inside a plastic tube 30 centimeters long, about 12 inches, the blood flows through up to 20,000 hair-fine fibers. Microscopic pores in the fibers filter out metabolic waste and excess water, which the dialysis fluid then carries away. As the blood cleansing process proceeds inside the dialyzer, a dialysis machine pumps the blood, administers anticoagulants, and monitors circulation. A treatment can take from 3 to 6 hours, usually 3 times.
From the interesting animation that we have watched, let come out with a clear explanation. During osmosis, fluid moves from areas on high water concentration to lower water concentration across a semi-permeable membrane until equilibrium. Hence, in dialysis, excess fluids move from blood to the dialysate through a membrane until the fluid level is same between blood and dialysate. As you can see, the figure provided also show how the water concentration occur in osmosis.
There are also other applications of osmosis. For example, when you keep some raisins in water, the raisins will get puffed. Or when you are in a bathroom for too long, you will realize that your fingers will get pruned and wrinkly. It all shows that osmosis is happening.
Why do our fingers get wrinkly?
Because they want to look like raisins.
No.
Huh?
A popular research suggests that wrinkly fingers are a reaction of our nervous system.
Oh.
When our fingers are in water for a long time, our nervous system causes the blood vessels present in the deeper layers of our skin to constrict. This in turn causes the deeper layers to shrink or contract. But as the topmost layer does not shrink, it becomes loose, thus forming small folds or wrinkles.
But why does this happen?
Scientists suggest that this could be an evolutionary adaptation. Wrinkly fingers help in getting a better grip to pick up wet objects, preventing them from slipping from our hands. Even our feet get wrinkly, helping us to walk in water without slipping.
That's how we showed to you about osmosis. We really hope this content will guide all of us to the correct concept of osmosis and apply in our daily life.
That is all from us. Thank you for watching.